Good morning, everyone. Today I'm going to be going over section 1.6, which is solving systems of equations by substitution and elimination. Hopefully some of this is going to be a review from Algebra 1. Please make sure you're taking notes on your own sheet of paper and following along. You probably also want to have a calculator handy to just double check all of your math. So when we're doing solving by substitution, it's really important that you guys have an x equals or a y equals set up already. If you don't, you're able to rearrange your equation so that way you have it in the form of x equals or y equals. The last thing I want to note about substitution is making sure you write your final answer as an ordered pair. So looking at this first example, we already have y equals an equation. So what we're going to do is we're going to substitute that into your second equation. So I have x plus 2. Instead of writing y, I'm going to have 3x plus 2 in parentheses equals 11. So I took my first equation and I substituted into my second equation. From here, you're going to go ahead and continue solving for x. So I get 7x plus 4 equals 11. That's going to give me 7x equals 7. So x is going to equal 1. From there, I still need to figure out what the y value is. So I'm going to take my x value and I'm going to substitute it back into one of the original equations. It doesn't really matter which one you choose. I'm just going to choose the top one. So that gives me y equals 5. When you put your answer together, make sure that you write it as an ordered pair. So the next question says, what does the solution represent? So thinking back to when we were graphing these lines, this point is a very special point. So the solution represents the point of intersection. All right, let's look at number 2. So if we look at number 2, we don't have a y equals or an x equals, but we can go ahead and rearrange one of my equations so that way it is set up. So I am just going to look at the first equation. I'm going to try to get y by itself. So to do that, I can go ahead and subtract 3x from both sides. Now, that can go right into my second equation. Negative 2x plus 4 parentheses negative 3x minus 7 equals 0. So just like the last one, you want to go ahead and distribute to solve for x. Be really careful when you're combining like terms. We should end up with x equals negative 2. From here, we still need to find y. Again, you can go back to one of the original equations. So I'm going to go back to the first one. And I'm going to plug in what I found for x. So if I do that, I get y equals negative 1. So my solution will be negative 2, negative 1. Make sure you're writing your answer as a point. So those are the only 2 examples we're doing with substitution. I'm now going to go and review elimination. So solving by elimination, you want to eliminate the variable that has the same coefficient but opposite signs. So let's clarify what that means. The coefficient is the number in front of your variable. opposite signs, that's referring to positive and negative. So same coefficient and opposite signs, an example would be 5x and negative 5x. So they have the same number, but they're opposite. One is positive, one is negative. You need to have something like that in your two equations before you can eliminate. If you don't, you're allowed to multiply one or both of your equations to get the same number with opposite signs. So let's go ahead and look at number 4. I see that I have 3y in both my equations, but they're both positive. I need one to be negative. So I'm going to multiply one of these by negative 1. It doesn't matter which one you multiply, but you need to make sure that you distribute that negative 1 to every single piece of your equation. And I'm just going to keep my first one the same. From here, I now have a positive and a negative coefficient. So I'm going to start my elimination process. You want to add both equations. So I get negative 1x, this goes away, equals 4. Now to get rid of the negative 1, I want to divide by negative 1. So I get x equals negative 4. We still have to find y, and we're going to do that the same way we did for substitution. So you're going to pick one of your original equations and plug in x. So I'm just going to go with that first one. Remember, it doesn't matter if you choose the first one or the second one. We should all still get the same answer. So I'm going to add 16 to both sides. I'm going to get 3y equals 18. Y is going to equal 6. So together, when I write my solution, I get negative 4, 6. All right, number 5. So number 5 looks a little bit different. Notice that our x's and our y's and our constants, they're not all lined up. So we do need to do some rearranging here. It doesn't matter which one you rearrange, either the first one or the second one. I'm going to go ahead and rearrange my top one. So I'm trying to get y just by itself. So I'm going to subtract 8x, I get negative 4y equals negative 8x minus 4. Now if I write my second one, everything is lined up. And I have a negative 4y and a positive 4y. So that means I'm all set up to eliminate. So let's add these two. This goes away, but we want to make sure that we're writing 0 there. Then we get negative 5x plus 10. Subtract our 10. From here, we are going to get that x equals 2. Same idea as the last one. We need to go ahead and find y. So I'm going to pick the second one. And that is going to leave me with y equals 5. So my solution, 2, 5. All right, let's get to one more elimination problem, and then we're going to do 2 challenging problems. All right, number 6. So in number 6, I don't have the same coefficient, so I don't have the same number with my variables, but if you look at my y values, I have a positive and I have a negative. So I'm going to go ahead and manipulate my equations so I can get the same coefficient. So you want to think about your least common multiple. So what multiple does 3 and 2 have in common? Hopefully your first thought is 6, but if you chose a different number, that is a-okay. So I'm going to multiply this by 2 and I'm going to multiply this by 3. Remember that you need to distribute to all 3 pieces. And then you want to go ahead and rewrite both your equations. So I have 4x minus 6y equals negative 10. 15x plus 6y equals 48. Now we're set up to eliminate. So we're going to go ahead and add our 2 equations. And that leaves me with x equals 2. Remember, you need to go back to find y. So I'm going to go back and I'm just going to pick my first equation. So I get negative 3y equals a negative 9. Y is going to equal 3. So my solution is going to be 2, 3. So the takeaway for number 6 is that you're allowed to multiply one or both of your equations. So that way you can get the same number but opposite signs. So keep that in mind as we get to the last 2 examples. Okay, we're getting into the 3 variable systems. These are a little bit more challenging. You're going to need to use substitution and you're going to use elimination to solve these. Something to keep in mind when you are solving these is you're going to do a double elimination. And that means to get rid of 2 variables. And then the second step is you're going to end up doing a double substitution. When you're doing these problems, please slow down and pay attention to your positive and negative signs. So the way I want to start this problem is I'm going to label my equations as A, B, and C. That way it's really easy to be on the same page with everyone. And I'm going to start by picking 2 equations that can go together so I can eliminate a variable. So I am going to go with B and C for right now. When I put B and C together, I am able to eliminate my y's. And I get a new equation. And I'm going to save that for my next step. Sorry, I'm going to save that for my second step. Let's now take 2 other equations. So we already used B and C. We're going to pick 2 other ones, and our goal is to eliminate y again. So the other 2 that I'm going to pick now are A and B. So I definitely had to use A because I didn't use A for my first pairing. So I'm taking A and B. Actually, let's go ahead and take A and C. And hopefully as I'm writing this, you're going to see why I chose A and C for my second pairing. So this is something that does not happen often. We are able to eliminate 2 variables. Usually, you're only going to eliminate 1. So we got rid of the x and the y. We're left with negative 6c equals negative 18. we can go ahead and divide by -6, and x is going to equal 3. I'm sorry, z is going to equal 3. So when you're doing these problems, you're going to start them the same way. You're going to pair two equations to eliminate. Then you're going to pair two other equations, and you should be eliminating the same variable. That's the key here. Eliminate the same variable. We kind of got lucky because x also eliminated in our second pairing. From here, you're going to put those two things that you got from your pairings together. So now, typically we would eliminate again, but since we actually have a value for z, we're going to actually start our substitution. So I have 5x plus 3 times 3 equals -1. And we get x equals -2. From here, I'm going to the last step, which is to solve for y. So I'm going to now take z and x, and I'm going to go back to one of the original equations. Let's pick equation C. So I know x is -2. We don't know y yet, but we know z is 3. So I have -2 plus 5y minus 3 equals -20. I get 5y minus 5 equals -20. And if I continue, I get y equals -3. So now I have my x, I have my y, and I have my z. So when I write my solution, you're going to write it in x, y, z form. So my solution is going to be -2, comma, -3, comma, +3. So looking back at the entire problem, we want to start here. This is our first step, where we're going to do eliminate a variable. Our second step was right here. And then our last step was right here. All right, number 8 is just going to be a little bit more challenging than number 7. So if you need to pause the video, go back, do what you need to understand this kind of problem. We're going to start this the same way. A, B, C. Remember, the first step is to take two equations where you can eliminate a variable. So I'm going to take A and C. If I do that, then my y's are going to nicely eliminate. And I'm going to save that new equation for a couple steps down the line. Now, you need to pick two other equations, but you have to eliminate the same variable. So I'm going to take B, because I haven't used B yet. And I'm going to pair it with C. So since you already eliminated y's right here, you need to eliminate y's again. But we're not quite set up for that. We need to multiply this top equation by 5, so that way we can eliminate it. So now, after I multiply, I am going to be able to eliminate. So I get negative 6x. My y's are now going to go away. Plus 25z equals negative 49. So in this step, you need to make sure that you're eliminating the same variable, or else you are going to get stuck on the next step. So after eliminating the y's, I'm going to put my two equations together. And I am going to eliminate another variable. So I'm going to look at trying to eliminate my x's. So it's not quite set up yet. I'm going to have to multiply my top equation by a negative 3. Now I am able to eliminate. The x's are going to go away. I get 4z equals negative 4. So z is going to equal negative 1. So I have one of my values there. All right, after finding z, I'm going to go back and I'm going to substitute z into one of these equations that I was just working with. So I'm going to use the first one. So I get negative 2x minus 7 equals negative 15. Negative 2x equals negative 8. So x is going to equal 4. Last step, we're going to go back to one of the originals and we're going to plug in our two variables. So I'm going to go ahead and pick equation B. And I'm going to plug in 4 for x and negative 1 for z. So I get y minus 12 equals negative 9. Add 12 to both sides. Y is going to equal 3. So if we backtrack a little bit, we have our solution. And we're going to write it as x first, then y, and then z. So just to recap, we did a double elimination. So we eliminated right here, we eliminated right here, and then we did two substitutions. Substitute, substitute. So just keep that in mind as you're doing these double elimination and double substitution. If you have any questions, please, please, please feel free to post in Teams or to email me. All right, you guys, thank you so much for watching. And again, let me know if you have any questions. Have a good rest of your day.